All right, today we're going to make a pool rack, and we're going to do this even though the part seems kind of simple. Seems like a good application of parametrics. When I did some research, I found out that the standard billiard ball is in American billiards is 2¼ inch diameter, and that's for an 8-foot standard table. And of course, in my basement, I don't have room for an 8-foot table, so I have a 7-foot table, and therefore the billiard balls on the 7-foot table are 2 inches in diameter. So let's see if we can tackle this with parametrics and end up getting two separate triangles for racking the pool balls out of this. So in order to do that, I've got a part already saved as pool rack, and let's see here. I'm going to want to modify my parameters. So I'm going to need to define some user parameters, and of course, let's billiard. Let's name this as diameter, and this is billiard ball diameter. So in inches, if we start out with the 2¼ inch billiard ball, that would be the diameter that we would want. And then the other user parameter that I'm going to want is probably going to be the height of the triangle. And for the height, I'm going to do the diameter divided by 2 plus 1/8 inch. So that way, what that will allow me to do is that will allow that the pool ball, the middle of the ball will be contacted by the rack, and it extends just slightly above the middle of the ball. If the middle of the ball was, if we don't make the rack high enough, then it's not going to contact the middle of the ball. So that's kind of why I'm estimating that amount, and we'll see how that works out. So this will be the height of the pool ball, or height of the rack. Okay, so we'll say okay. So I have a diameter and a height defined as user parameters. So that way I will size the rack based on the size of the billiard ball that we are making the rack for. Okay, so let's start a sketch, and it doesn't really matter what plane we draw it on, so front or bottom. And let's draw one circle. And when instead of putting in a diameter, we want to type diameter, and if you start typing it, you could just click on it, so it'll size that one cue ball to be the correct size. Now in total there's going to be 15 circles, so then what I'm going to do is just draw a whole bunch more circles. Okay, so next, using the equals constraint, let's make them all equal to the first one. And once they are all the same size, we will make them all tangent to each other. So we'll make and go add our tangent constraint. And you'll notice, since they are not exactly straight, let's use a vertical constraint and line up the first one with the third one. So now it's starting to look like a pyramid. Okay, there we go. We have a fully constrained pyramid set of billiard balls. Okay, so now we're going to start drawing our triangle. And let's just eyeball a line segment. Let's just eyeball 3 line segments actually. And make sure they're outside of the shapes. Or if they're inside, it'll work out. So let's make the tangent to the first one and the last one. So that will make it line up. Do the same thing on the other side. And then this other one needs to be horizontal. And then I'm going to draw an additional line here that's going to be horizontal. And I want that one to be a construction line. So if I right click, I should be able to make that into a construction line. And then let's also make that tangent. And the reason for that is we need room to get our fingers in here. That's why this is not perfectly sized to each one, because we need room to get our fingers in here in order to push the balls tight up against this end of the triangle. So therefore, what I need to do is let's put a dimension in there that the distance between the construction line and the other edge of the triangle is 1/2 inch. Okay, and once I have that, I should be able to offset and make the triangle 3/8 of an inch in thickness, 0.375, although that needs to be a regular line, not a construction line. So that'll make the triangle 3/8 of an inch in thickness. So then we go ahead and finish the sketch. And then we can extrude that. Of course, the distance would be the height that we defined based upon the size of the diameter of the balls. Okay, and what we'll also notice is we need to add some fillets now. So if I go in and add the fillet for at least all of those corners, and the fillet size, of course, should be the diameter divided by 2. So there we go. There is the pool rack sized for 2 1/4 inch billiard balls. Okay, just for fun, I can turn my sketch back on visibility to see what that looks like. And then if I use the inspect tool just for comparison, we'll use this here in a second. If I measure, looks like 10.876 inches for the length of my edge on my billiard rack. Okay, and this is for the standard pool rack. So if I do save as, I'll name my new file as pool rack short for a short table. And then let's go into modify parameters. And if I go in and change that one parameter, instead of being a 2 1/4 inch diameter, let's make it 2 inches. So we make it 2 inches, and as soon as I did that, you actually saw it change sizes. So everything else stayed the same. It got a little shorter in height, of course, because that was tied together parametrically. And when I inspect that measurement, now it is only 9.876 inches in distance. And a minute ago, it was what, 10.876. So it made it, of course, a little bit shorter. Okay, so cool, very kind of a simple part to do, but kind of a cool application of parametrics.